Next question says Fred cycles up a hill at a constant speed of 5 kilometers per hour. And then he cycles down the hill at a constant speed of 45 kilometers per hour. Number 8 says, what is his average speed? So they're telling us that Fred cycled up the hill at a speed of, not 45, the speed of 5 kilometers per hour, and down the same hill at a speed of 45 kilometers per hour. Okay, so let's take the distance up and down the hill to be d. Okay, now average speed is equal to total distance divided by total time. Okay, it's not 5 plus 45 over 2 and you get 25. Okay, when we deal with average speed, we don't do that. Okay, so please don't do that. Now, let's calculate what is Fred's total distance going up and down the hill. So, total distance will be equals to d going up the hill plus d going down the hill, and this will give us 2d. And total time, we'll use our formula, distance over speed. So going up the hill, it will be the distance d divided by the speed of 5 kilometers per hour. And we will add the time going down the hill, which will be d divided by the speed of 45 kilometers an hour. Okay, so we add the two fractions, find the lowest common denominator, change the 5 to 45, we need a 9, so this will be 9d divided by 45 plus d over 45, and this will simplify to 10d over 45. Let's take that up a little bit and simplifies further into 2d over 9. Okay, so therefore the average speed will be equals to our total distance, which is 2d, divided by the total time, which is 2d over 9. Okay, and we get an average speed of 9 kilometers per hour. Okay, because 2d will cancel 2d there, leaving only 9. Now, number B says if he is able to increase his speed down the hill, what is the maximum average speed he will be able to achieve? Okay, so let's try to think about that for a moment. So that's for number B. So going up the hill, he is still moving at 5 kilometers per hour on distance d. But going down the hill on the same distance d, we want to find out if he can increase that 45 by a certain number x, or by a certain speed x. Okay, so we do the same thing as we did with the first question. So average speed still equal to total distance divided by total time. Okay, and our total distance is still 2d, so this is still equals to 2d. Now, because the length hasn't changed, now let's simplify the total time. So for total time, still going up the hill is still d over 5, But now going down the hill, it will be d divided by 45 plus some certain distance x, which Fred wants to increase his distance by. Not his distance, but Fred wants to increase his speed by. Okay. So let's try to simplify this fraction. So here we need LCD is 5 into 45 plus x. So this will be d into 45 plus x divided by 5 into 45 plus x. And we adding, here we need a 5, so this will be 5d divided by 5 into 45 plus x. Okay. And then let's try to simplify this. This will be equal to d into 45 plus x plus 5d all divided by 5 into 45 plus x. And then if we factor out the d, we get d into 45 plus 5, which will be 50 plus x. And this is still divided by 5 into 45 plus x. And that is our total time with the increased speed going down the hill. Now, our average speed, if we substitute our total distance and total time, so our average speed will be equals to 2d, that hasn't changed, divided by total time, which in this case will be d into 50 plus x divided by 5 into 45 plus x. Okay, so let's tip and times. Then we get 2d multiplied by 5 into 45 plus x all over d into 50 plus x. Okay, so d and d can then cancel once again. And then we end up with 10 into 45 plus x divided by 50 plus x. Okay. Now, we need to sort of bully this into giving us some, because from looking at this expression that we have, we don't know as x increases what actually is happening to this fraction. So let's just bully it a little bit. Now I will multiply or distribute the 10 in the numerator, and I will get 450 plus 10x. Okay, and this will be divided by 50 plus x. Now, since I want to get a whole number at some point in the numerator, I will write 10 into 50 plus x. The reason why I chose a 10 is because I see there's the coefficient of x, there is 10, because I actually want to have 50 plus x on its own. So if this number was 5, I was going to have a 5 here. This number was 100, I was going to have 100 here. So this is divided by 50 plus x. Now, if you look at this expression, if I start to distribute the 10 into that bracket, I would have 500 plus 10x. While in the previous expression, I had 450 plus 10x. So there seems to be a 50 extra, okay, because it's going to be 500 plus 10x. So I must subtract that extra 50 so that I keep the nature of the expression the same. Okay, now separating this bracket, I would have 10 into 50 plus x over 50 plus x minus 50 divided by 50 plus x. Okay, so we can see now that that cancels that, and we are left with 50, not 50, sorry, 10 minus 50 all over 50 plus x. Okay, now there we go. So if I look at this fraction here, as x gets bigger and bigger, this fraction here becomes smaller and smaller. Okay, so remember, x represents some speed that he wants to increase as he goes down the hill. Okay, so as he increases his speed going down the hill, his average speed will only decrease by will only increase by a small fraction. Okay, so the maximum speed seems to be very close to 10 as he increases his speed going down the hill, but it will never actually be 10 because we are always subtracting a very, very small number from 10. Okay, so as he increases his speed further and further and further, then we are subtracting even a smaller number from 10, but we will never actually reach an average speed of 10 kilometers an hour. So in this case, we say that the maximum speed is unattainable. Okay, so this question B wasn't as easy. So this one says, A and B ran a race of 800 meters on a circular course having a circumference of 250 meters. They start together but run in opposite direction. If A wins by 40 meters, how far was B from the starting post when A passed it the first time? So we are also given a sketch to show us A is running that direction, B is running that direction. Okay, so first thing that we have to consider here is that A wins, right? So A, okay, use black. A runs 800 meters, and that means B runs 760 meters because A wins by 40 meters. That means B was 40 meters behind A when A won this race. So this is a proportion problem that is not so easy to see, but if we use ratios, we will see that after A, so let's say A is to B there, will be 800 is to 760 because after A runs 800, B is only 760 meters. Okay, now if we put 250 here as the circumference of the circle, we can divide going up and multiply across. So this means that after A runs 250, B will run some distance that is less than 250. Okay, so we have 250 divided by 800 multiply by 760. Okay, so the 2 zeros there will cancel the 2 zeros there, and 4 goes on to 8 2 times, and it goes on to 76 19 times. So we have 25 multiplied by 19 over 2, which gives us 25 multiplied by 9.5. So 25 multiplied by 9, it will be 225 plus half of 25, which is 12.5, and that will give us an answer of 237.5. So what this means is that after A runs the circumference of 250, B only runs 237.5. Okay, so how far was B from the starting point? We would have to take 250 and subtract 237.5, and our answer here will be 12.5 meters from the start. Now, this problem says between 12 and 1, there are 2 times when the hands of a clock are exactly at right angles. Okay, so there are 2 times. How many minutes apart are these 2 times? Okay, so let's try to do this problem step by step. First of all, we know that the minute hand moves 60 minutes in 1 hour. That's in between 12 to 1. And we also know that the hour hand will only move 5 minutes during this hour. Okay, now it is clear that if the minute hand moves 60 minutes in 1 hour and the hour hand moves only 5 minutes, that means the minute hand, so we can say therefore the minute hand is 60 over 5, which is equals to 12. So it's 12 times faster than a hour hand. Okay, so we know that the minute hand is 12 times faster than the hour hand. Now, what does this mean? So if we take a clock, let me try to draw a circle here. So if we have a clock, if it's 12 o'clock, they are both at 12, right? But the minute or the second the minute hand starts moving, the hour hand is also moving. Okay, and then that means we will achieve a 90 degrees when the minute hand has passed 3. So the minute hand will be here, the hour hand somewhere there, for example, and we would have a 90-degree angle there. Okay, so if the minute hand has moved X minutes, that means the hour hand has moved what? And the hour hand has moved X over 12 minutes, because it's 12 times slower than the minute hand. And then we can now define the minutes between the minute hand and the hour hand. So the minutes between, I'm just going to say minute with the subscript of B there, the minute between the minute hand and the hour hand will be equals to X multiplied by X over 12. Okay, there's the minutes in between the minute hand and the hour hand after the minute hand has moved X minutes. Okay, so we can simplify this into 12x over 12 minus x over 12, and we get 11x over 12. So what this means is, at any point, we can define the minutes between the longer hand and the shorter hand, or the minutes between the minute hand and the hour hand, as 11x over 12, depending on how many minutes there did the minute hand move. Okay. So we also know that the minute hand moves 60 minutes in an hour. That means if we take 360, since it moves 360 around the clock, and we divide this by 60 minutes, that means the minute hand actually moves 6 degrees per minute. Okay, so the minute hand moves 60 degrees per minute, and if this is the minutes between the minute hand and the hour hand, that means that the angle between the minute and the hour hand will be equals to 11x over 12 multiplied by 6. Okay, because these are the minutes between the minute hand and the hour hand. If 1 minute is 6 degrees, that means the minutes between the minute hand and the hour hand multiplied by 6 will be the angle between them. Okay, and this will simplify to 11x over 2. Now, this is the angle between the minute hand and the hour hand. Okay, very important to follow here. So here is the minutes between the minute hand and the hour hand. If the minute hand has moved x minutes, and this is the angle between the minute hand and the hour hand if the minute hand has moved x minutes. Okay, now we want this angle to be 90. So we will calculate how many minutes must the minute hand move so that the angle between the minute hand and the hour hand will be 90. So 11x over 2, we want this to be equals to 90 degrees. Okay, so if we solve for x here, we get x will be equals to 2 multiplied by 90, which is 180, divided by 11. Okay, so this is the first time actually the minute hand and the hour hand will have a 90 degree angle between them. There will be a second time when if that is 12 there will be a second time when the hour hand is almost there at 1 and the minute hand is almost at o'clock. But in this case now, the angle between the minute hand and the hour hand will be 270 because we want this to be 90. Okay, so we take our expression again for the angle given the minutes that the minute hand has moved. So we'll take our 11 over x over 2, which is the expression of the angle between the minute hand and the hour hand if the minute hand has moved x minutes, and this must be equals to 270. Okay, and now if we calculate x, 270 multiplied by 2 is equals to 540 divided by 11. Now we have this case, the first time we reached a 90 degree angle between the two hands, and we have here, which is the second time we've reached a 90 degree angle between the two hands of the clock. Now the question says they want how many minutes apart are the two times when the minute hand and the hour hand were 90. So we have this and this. So how many minutes apart? Now we take 540, black pen. We take 540 divided by 11, and we subtract 180 divided by 11. Okay, so 540 minus 180, so this will be 360 divided by 11. Okay, minutes. So these two times are 360 over 11 minutes apart. If you want, you can, which is about 10 to 20, which is about 32, and the remainder will be 8 over 11 minutes. So just above 32 minutes, when the two hands of the clock will be about 90 degrees from each other. So this problem says 14 schools participated in a fundraise. If there were 1,350 participants, prove that one school was represented by at least 97 learners. Okay. Now, you will hardly ever be asked a problem like this in the Olympiads, but let's just do it for extras. Okay. So if we assume that each of the 14 schools had equal participant, we will take 1,350 divided by 14 to find how many participants were in each school. But if we do that, we get an answer of 96 and a remainder of 6. So there is still 6 extra learners even after we divided all these participants across the schools. Okay. Now, to prove that there were at least one school that had more than 96 participants, we can see if we take all the learners and divide them equally into the 14 schools, each school will have 96 learners, but there will still be a remainder of 6 participants. Okay, so these 6 participants will actually belong to one or more schools, proving that at least one school had more than 96 learners. Okay, so at least one school had 97 learners. Okay, so if I'm saying at least one school had more than 96, that actually means at least one school had 97 learners. So this problem says 5 points are placed inside, not on the boundary of an equilateral triangle having side 1 unit. Show that there are 2 points among these 5 which are less than 0.5 units from each other. Okay. Now, if I draw an equilateral triangle here, let me put it here. So I can just place 5 points randomly in this triangle. But how do I actually prove that 2 points among these 5 will have a distance less than 0.5 units? So I know this equilateral triangle has side length 1, 1, and 1. So the trick here is to actually divide this equilateral triangle. Okay, so if I take a midpoint here and the midpoint here and the midpoint there, then I can divide this triangle. So let me delete those points there So if I divide this triangle in this manner, that means that each side of all this smaller triangle will be a half, 0, 0,5, 0, 0,5, 0, 0,5 there, 0, 0,5 units, 0, 0,5. This will also be 0, 0,5 because I divided the triangle into 4 equilateral triangles. Okay, 0, 0,5, 0, 0,5. Okay, now I have 5 points that I need to place in this 4 equilateral triangles. Okay, so I can place a point here, use a different color. I can place a point here, I can place another one here, I can place another one here, and another one here. So of these 4 points, it's possible that they will always have a distance between them that is more than a half, because each side of the smaller equilateral triangle is a half. For example, I can shift that point and place it there. I can shift this one here and place it there. I can shift this one and place it there. So what I've done really is to make sure that these 4 points have a distance that is more than a half between them. Okay, but then there are 5 points, and there's still 1 point that I must place inside this equilateral triangle, but not in the boundary. Remember, that point should not be in the boundary. So this point can either be inside this equilateral triangle here, the one at the top. In any case, if I place it inside this equilateral triangle, that means the distance between this one and this one will always be less than a half, because the longest side of this equilateral triangle is a half. So the only time I would have a distance that is equal to a half between these 2 points is if I place them exactly in the edges, and according to the question, we must not place the point on the boundary. Okay, so even if I shift it to a different triangle, it will still have a distance of less than a half unit with this point that is already inside that triangle. So from here we can see that there will always be a triangle. So some triangle will contain more than 1 point, or you can say some triangle will contain 2 points. Okay, and these 2 points will obviously be less than a half unit from each other, because the longest side of that triangle will be a half itself. Okay, I hope that makes sense. Okay, so we divided this equilateral triangle into 4 equilateral triangles, but because we have 5 points, we have successfully placed the 4 points with a distance of more than a half units from each other. But the 5th point must fit in one of these triangles, which will result in a distance between the 2 points inside the triangle being less than a half. This problem says, let A be any set of 19 numbers chosen from the arithmetic sequence that. Prove that there will always be 2 numbers in A whose sum is 104. So let's just write the first few numbers. We have 1, 4, 7, 10. Next one will be 13. The next one 16, and the list goes on and on. And the ends up to 100. There's 97 there. There will be a 94 there. Will be a 91 there. There will be an 88 there, and so on. Okay, so first of all, notice that 4 plus 100 is 104. 7 plus 97 is 104. 10 and 94 is 104. 13 and 91 is 104. Now, what is happening here? First of all, let's find how many numbers are in this sequence so that we can have an idea of how many pairs are there. So, we know that Tn is equals to A plus n minus 1d for arithmetic sequences. So the last term, which is 100, is equals to 1 plus n minus 1. The difference is 3. We want to find n to see how many terms are in this sequence. So 100 minus 1 will be 99 divided by 3 plus 1 is equals to n. Then we get n will be 33 plus 1, which is 34. So there's 34 terms in this arithmetic sequence. However, 1 will not be paired with anything because there is no 103 there. Okay, so 1 will be a loner, will not have a pair. But there's another number that will not have a pair. And that number will be 52. How do I know that? Because to get 104, we will need 52 plus 52, which is 104. And we only have 152 in this sequence. Okay, so we know that 1 and 52 do not have partners, so we can't pair them together to give us 104. Now, there are 16 pairs of numbers in this sequence which will give us the sum of 104, and there are 2 numbers that can be paired with anything. Okay, so assume that we take one number from each pair, then we would have 16 numbers plus these 2, then we would have 18 numbers from the sequence. Okay, so if we have 18 numbers from the sequence, that is one number from each pair, and we have the 2 numbers. The minute we start adding another number, then it will have one of the numbers from the 18 which has a pair. Okay, don't know if that makes sense. So we want to choose, we have 16 pairs that when we add the 2 numbers, we get 104. We have 2 numbers that we can't pair with anything to get 104. So we choose 16 numbers, that is one number from each pair, plus the 2 numbers, we get 18 numbers. The minute we choose the other 19th number, it will have another number here, which when we pair, we get 104. Okay, hope that makes sense. Given 2 integers a and b, consider the number ab into a minus b. Can you determine if it is even or odd? Okay, now to answer this question, we need some knowledge of what we call parity. Okay, so parity is basically the property of a number to either be even or odd. So if we take even numbers as E and we take odd number as O, we must remember that an even number plus an even number will give us an even number. An even number plus an odd number will give us an odd number. Even minus even number gives us even number. Even minus odd will give us an odd number. and odd minus odd will give us an even number. Okay, and then even multiplied by even will give us an even number. Even multiplied by odd is even, and odd multiplied by odd is equals to a odd number. Okay, now having all this information, let's look at what we have here. So this number here is even if a, so ab into a minus b will be even if a is even. So if a even, this number will be even. If b is even, this number will be even. If so if any of a and b are even, the whole number is even. Okay, now let's look at the situation whereby, what if a is odd? So if a is odd and b is even, this will still be even because we are multiplying the odd number a by the even number b. The same thing is b is odd and a is even, then the whole thing will still be even. So if either a or b is even, then this will be even. Now, the only thing to consider, what if a is odd and b is odd? So we go to this property here where we say an odd number minus an odd number is equals to an even number. Okay, so even if both of them are odd, that is still even. Okay, now we can write all this combination. So if we define this as a is to b, first combination, a is even, b is odd, we will have an even number. A is odd, b is even, we'll have an even number. Both are even, we'll have an even number. Both are odd, we will have an even number because an odd number minus an odd number will give us an even number. Okay, so we can conclude that AB into A minus B is always even.